Hi, everybody. My name is Rachel Deininger, and I'm presenting today on virtual plot alignment for forest inventory in wilderness areas. So first, I want to present myself and my team. I'm a LiDAR analyst with the University of Washington in the Fling lab, and my team is Spencer, who is a PhD student at the University of Southern Australia in the virtual reality lab and wearable computer lab. Now, for this project, both Spencer and I are independent of our jobs and degrees. This is a project that came on because we're both passionate about the topic, and we also saw potential in it and how it could work. So this is something we've actually been doing in our own time in addition to work and for Spencer graduating.
So getting into it, we've been working on a tool that uses virtual forest plots for navigation. To explain why and where this idea came from, I need to kind of pull back in the narrative a little bit and talk about when I actually started my master's experience. So I did multiple field seasons up in Alaska, for the first one outside of Anchorage and the other outside of Fairbanks. And this is where I began my collaboration with the Forest Service to see how terrestrial LiDAR could be incorporated into forest monitoring. The specific program I worked with is called FIA, or Forest Inventory Analysis. FIA is a program that monitors forests across the US. They conduct a forest census approximately every 10 years, and they visit plots like the one here. And they collect things like the diameter, the height, the coarse woody debris, and so on, a bunch of manually collected data about the trees on the plot. If you are conducting one of these long-term monitorings, it's very important that you can get to the exact same place over and over again. And that means the exact same plot center. You can measure things out. Make sure you're seeing the same trees 10 years later. So FIA plots are marked with things like pins and witness trees, which can take a lot of searching through the debris to actually find. But once you find them and establish your plot, then you can get to monitoring it. While GPS navigation can get you on plot, it's far from being specific enough to get you to a plot center. And that's where this permanent monumentation comes into play. Now, you can't talk about fieldwork without talking about the travel. And first, getting all the gear up there. It's quite a lot, and it tends to be heavy. We often had to shuffle around what was in our bags because we exceeded weight limits, which is a fun thing to do while you're standing at the airport in line. Now, beyond that, there's going on ATV. When that doesn't work, by boat. And if the terrain just gets too difficult, hiking across marshes in this case. Now that you really have a sense for how rural some of these plots are, I think it's a good time to ask this question: what is wilderness? And you see, I'm bringing things back to the title now. None of the FIA plots we visited were wilderness, as remote as they were. And here's why. So in the US, wilderness was first defined in 1964 by a set of 5 qualities called wilderness characteristics. And they are natural, untrampled, undeveloped, opportunities for solitude or primitive and unconventional recreation, and other factors. So the one that really conflicts with FIA's protocol is the undeveloped, because as it states, permanent improvements in wilderness make it not wilderness anymore. So any permanent monumentation that you're putting in there to be able to monitor these plots, you can't have that. It means you can't find your plot. So this brings us to our problem statement. Permanent monumentation cannot be established. And here's some more examples of what that monumentation looks like. So this means across all of the wilderness in the US, a lot of it being in Alaska, there's no monitoring of it in our national inventory of trees. So we came up with a solution that incorporates some pretty cool technology. And we were proposing to use detailed terrestrial laser scans for navigation, which is something they haven't really been used for, even though they've been brought up in monitoring purposes. And if you remember, I was in Alaska originally collecting LiDAR scans for a completely different purpose. But this gave me like the background and the necessary knowledge to start investigating this. Now, before I get into it more, I want to make sure we're on the same page about LiDAR. So light detection and ranging, it's an active remote sensing device which creates a 3D point cloud of the objects it scans. It's used for making topographical maps and 3D models, and in self-driving cars that are actually self-driving. And if you work in forestry, you're probably most familiar with aerial LiDAR. The ones we're going to be talking about are terrestrial and mobile laser scanning, but I'll just talk about these briefly and then get back to our tool. So terrestrial laser scanning uses a stationary LiDAR device, usually mounted on a tripod. And to avoid occlusion, you have to take scans from multiple angles because you can't see through things. So you have to look at it from multiple directions. This means you have a lot of processing time where you're stitching together scans, which is where those orange lollipops come in. These large orbs that we put out in the woods are points that we know the exact size of, and we know that they are the same in multiple scans. You can stitch the scans together, get one point cloud. It's time consuming, but it's very detailed, and the clouds look really good. Now, mobile laser scanning tends to be faster because you're walking through the plot and it's doing the stitching for you as you walk using the SLAM algorithm, simultaneous location and mapping. So this is less processing time in the end, and there's actually been a lot of improvements as to the detail of mobile laser scanning. For the purpose of this presentation, I'm just going to talk about them as both being TLS. And frankly, mobile laser scanning is also terrestrial. The whole naming convention is complicated. If I want to talk about the multi-scan tripod-mounted LiDAR, I'll call it stationary. All right, so using LiDAR and TLS specifically in forest inventory is a fairly hot topic, and it's being investigated not just in the US, but in many countries as well. And so it's becoming a lot more common, and we're kind of looking at a future where this sort of technology is being used in forest monitoring. We've seen a lot of improvements, especially in things that I've spent a lot of time doing, like tree segmentation. Here you can see an over-segmented and an under-segmented tree, and our perfectly segmented tree in the middle. And even with my own masters, I was able to segment some of these plots and line up the terrestrial point clouds with the manually collected FIA ones and get a direct comparison between our terrestrial metrics and the manually collected ones. Those are the ones I matched. They looked great. Okay, but back to what we're here for, virtual plot alignment tool. So how will we use LiDAR to solve this permanent monumentation problem? It's not a metric we can calculate, it's something very different. And our solution is to create virtual plots. Essentially, our goal is to let you walk through the point cloud. And once you line it up with what you're seeing in front of you, then you're able to find the marked locations. Now, I have some demos of some of the usability tools we've been working on and little videos of them, so I'm excited to show these to you. They do show parts of a campus in Australia, so that's cool. You wouldn't be able to tell if I didn't tell you. All right, so here we have something for manually lining the cloud in space. The cloud's floating up in the air, you put it down to the ground, you tell it this is ground, and it moves the cloud closer to the ground. So it's easier to get that first step of walking into the point cloud. Now they're adjusting the point size. So in this case, you can see like a building there, but clearly you changed the point size and it's not aligned right now because when you're actually looking through it, you can tell that there's not a building behind that. Right. Another, changing the point's colors. So if you're aligning a true color point cloud to a true color image in front of you, it can get really cluttered and be harder to align. So these are all things that will help in the process of moving the point cloud around to the right position. Now we use the locating the virtual markers. So here we have our purple spinning arrow, and as he gets closer, you can tell exactly how close of a point you get. So you have that marked in your point cloud, you can get to something very exact, which is exactly what you need for our FIA plots in theory. And the last one is just on how it kind of looks to align the point cloud. You're just moving it around, aligning it with an object, and then you're changing what angle you want to look at it. You walk around, look at it from a different angle, be like, actually, I've only lined it up on one axis, need to line it up on this one. It's very similar to the experience of registering point clouds in Cloud Compare, if any of you have done that before, at least manually doing it. But it's a good start. Now I've talked about some of this usability improvements we've made. I want to talk about some of the possible future ones. So we really want to start integrating the handheld LiDAR in real time. So a lot of iPhones and iPads nowadays have a basic form of LiDAR. And if you can use that to sense the ground or sense something in front of you and then register it with the actual point cloud, tell it these 2 points are the same, it'll help with the lining process. We'll also want to include a small map for navigation, so you know where you are within your point cloud, and a way to save annotations. Because theoretically, if field techs are taking this into the field, it'd be great for them to have a space to write down notes that are specific to locations or trees. Now, back in April, I was part of a program here at UW called iCore, which is an entrepreneurial trading program funded by the NSF. It was different waters for me as an ecologist. But as a part of this, I conducted 20 interviews in a month. It was a lot of emails to different researchers who might be interested in this or who had a lot of alignment in what I was researching as well. And there were a range of sectors that we talked to. And you can see some of the different groups and organizations here. Here's some of what I learned from them. So many of the groups really had low alignment with the project. This isn't going to work for everybody, and it's not going to appeal to everybody. For example, things in R&D aren't necessarily budgetable for all organizations at that time. Of course, fire ecologists didn't have much use for it because oftentimes if a plot completely burns down, you don't have any trees to line your point cloud up, but it looks different. And usually you establish a new plot because you don't have the same trees to monitor. And then private industries, they don't care about permanent monumentation. They own the forest. Now, there were some groups that had really high alignment, like very specific projects that were like, hey, we're into TLS. Wilderness groups were very excited to hear about it or to talk about this. And many groups and some that had future projects was aligned with LiDAR in general. So those that were kind of already interested in incorporating LiDAR, had an interest in LiDAR, seemed to align better with the project. I want to go over some of my key findings. Like the GNSS these are things that I heard across many interviews and kind of gathered together as my summary of it. So GNSS is less accurate under canopy cover. It's a problem that was run into by a lot of people. Manually collected forest metrics frequently have recording errors and accuracy errors from the users. Think about measuring DBH if you have two people that are completely different heights and they're both trying to guess what breast height is. You can end up with a different measurement of the tree, or in the case of FIA, some plots where the trees shrink. Another one is there's no way to look at our past data. So once you've manually collected it, you can't go back to check to see if it was wrong because it's 10 years later. And then accuracy and more validation training data is necessary for aerial. So we kind of summarize those together and we look at like, what are the uses for this beyond navigation and how does it encourage or promote the use of TLS for like national inventories in general. So we look at having a permanent record. So if you record, you scan a plot, you have a permanent record of the structure of those trees. No matter how the processing changes over time, you're always going to be able to go back and reprocess. So even if the methodology we use changes, we can still go back in time and have the same data and process it in the same way. In contrast, if you want to measure something in a different way manually, you're never going to be able to start. You have to start over. You're never going to have something to compare it to until you've been doing it for a long time. Also, the improved analysis over time, TLS is like vastly improving even during the course of my master's. Like the segmentation has improved a lot and it's become a lot more open source. Useful for developing projects in species classification. I think this one's really cool because that was part of what I did for my master's, but you need a lot of training data for that. And so just collecting more TLS data means you get more training data and more validation data for aerial devices. So now, how does the tool fit into this? We know TLS is great, clearly. Well, this tool is a first step to improving virtual reality interfaces into forest inventory. So it promotes the use of TLS in forest inventory and makes it more accessible, as well as approaching this permanent monumentation problem that we're seeing in wilderness areas and the fact that we're not monitoring them. All right, so this is a glacier I saw in Alaska. Any questions? Yes?
You mentioned SLAM algorithms.
Yes.
Do you feel like the advancement of like the research with LiDAR and self-driving cars, is that big push in that research what help with FIA and whatnot, or do you have a sense of that?
So the question is about whether or not the progress of research with self-driving cars also crosses over with the progress of research that FIA would use. As far as I know, not really. And a big part of that is actually like lack of transparency between fields and using different names for things. Is the fact that if you're in a different field, they often have different acronyms and names for things, and so there's not a lot of sharing that happens there. I haven't looked into it too much, but I haven't seen any like self-driving car particular things that have crossed over. Now, forestry itself is like a slightly unconventional use of terrestrial LiDAR, much to the chagrin of many of the LiDAR companies, which have to deal with our technical calls. Or devices that didn't realize they were going to be looking at organic objects, those being much more complicated. Yes?
Do you have a sense of the scale of the data size for these plots that you, like the raw data, how much space it takes up? I imagine it's a lot of points.
Yes.
I'm curious.
Yes.
The data storage implications of that.
Yeah, so for example, one of my subplots on a plot in Alaska with like 5 scans would have several million points. And a lot of the like plots I end up working with are hundreds of thousands of kilobytes. I have a lot of storage. I've like got many hard drives.
How limiting did you find the hardware to be in rural and backcountry environments?
Well, we brought a lot of the hard drive hardware with us, so we were like hiking the scanners out there to the plots. Let's see, limiting things from that. It's kind of stressful to carry $100,000 worth of gear on your back in moose country. We had one instance where we were setting up a plot and then we got chased off the plot by 2 moose. And then we had to sneak back on plot to get our gear because it was very expensive. And also I was like a week away from starting my master's, so I wasn't even the student yet. I couldn't destroy the lab's gear before I even started. Yeah, and then had to sneak out again. The moose are very mean. Yes. So usually the gear worked, but there were instances where some instruments had, specifically the BLK with Leica had critical failure issues, and we had to send it back to like Switzerland, and their customer service was not very helpful, which is why the Zeb Horizon in Faro is great. Yes?
In one of your photos, the person in the photo had a kind of big mask on, and at first I thought, is that an insect screen for the Alaskan mosquito? Then I thought, is it needed for the LiDAR device?
No, that is for the mosquitoes. That was me. There were a lot of mosquitoes. Yeah. Okay, I think that's all the time I have, but thank you all.